Here we're going to look at question 73 from the IMAT 2011 paper. So in this question we're given the following circuit, which has a 20 volt battery connected to 3 resistors, a 5 ohm resistor, a 10 ohm resistor and a variable resistor with resistance R which can go between 0 and 5 ohms. So what the question asks us is to sketch a graph of the current I through the circuit against this variable resistance R. So if you'd like to have a go at doing this question yourself, then please pause the video now, otherwise we'll have a go at doing it together. So to answer this question, we need to try and think of some way of finding the current, or some expression which is going to have current in it. And whenever we use circuits, generally speaking, the equation which should come to mind, or the law, is going to be Ohm's law. And this equation is basically just that the current through a circuit is equal to the voltage across it divided by the total resistance in it. So we can actually try and apply this law to this circuit here to get the total current through it by taking the total voltage, which of course is going to be 20 volts since that's the voltage across the battery, and dividing it by the total resistance, which is going to be given by the resistance of this section here made up of our 3 resistors. So what we have to do is try and find an expression for the total resistance, and then we can find an expression for our current. So to find our total resistance, we need to find the resistance of these 2 parallel sections, these 2 parallel systems of resistors. And whenever we have resistors in parallel, we have to use the rule of adding the reciprocals of our resistances to get the reciprocal of our total resistance. So 1 over the total resistance is going to be equal to 1 over our 10 ohm resistor, given here, plus 1 over the resistance of this branch, 5 ohms plus R ohms. What we can then do is just substitute this, or simplify this expression, So if we multiply each by the denominator of the other, then this becomes 5 plus R over 10, and this becomes 10 over 5 ohms plus R, of course, add together to give us this, which we can then just simplify to get a total R value of 10 multiplied by 5 plus R over 15 plus R. Then, to get our expression for current, all we have to do is substitute this back into our original equation, which we had at the top here, giving us that we have 20 volts multiplied by 15 plus R divided by 10 multiplied by 5 plus R, which and then the 10s, are going to cancel out, giving us this factor of 2 on top, which simplifies to this expression here. So to sketch our graph of current against R, we can just use this equation, which we put up here on this next page, and we can try and test some values of this graph to see if we can get a nice sort of idea of what the graph will look like. Now we know that the resistance R goes between 0 ohms and 5 ohms, so let's test each of these extreme values and see what comes out. If we begin with R equals 0 ohms, then we can substitute 0 in for R, and we should get that I is going to be equal to 2 multiplied by 15 divided by 5, which of course is just 30 divided by 5, or 6 amps. Doing the same thing with the upper ranges of the resistance, 5 ohms, then we should just get that I equals 2 multiplied by 15 plus 5, or 20, divided by 5 plus 5, which is 10. So of course this is just 40 divided by 10, or 4 amps. Knowing then that R equals 0 gives us a current of 6 amps, and R equals 5, giving us a current of 4 amps, we can just look at the answers which are actually given in the question and see that they're going to match up to the following graph best. This can of course also be deduced from the R value, since we would expect our current to decrease as the resistance increases based on this equation and based on the activity we've seen here. So this is just going to correspond to answer E, which we're given in the question.